This lesson is about the Ferris wheel, and we use it to introduce the topic of trig graphs. Let's start by reading together. To celebrate the new millennium, the British plan to construct the world's largest Ferris wheel. The London Eye, or Millennium Wheel, is located in London, England, and measures approximately 500 feet. It turns continuously and completes a single rotation every 30 minutes. They wanted it to be slow enough for people to hop on and off while it rotates. So far we know that the height of the Ferris wheel is 500 feet and that it takes 30 minutes to go all the way around. Assume the wheel is turning counterclockwise and your height above the ground h of t in feet is a function of t, which is the number of minutes you have been riding. You decide to ride the Ferris wheel for 3 full turns and you hop on at time t equals 0 at the 6 o'clock position. We want to go ahead and make a table of our information here for our time. Notice we're going in 7.5 minute intervals. Let's talk about why that might be. And our height as a function of time. So if I start at t equals 0 and I end up after 30 minutes at that same spot, it would take me, of course, 15 minutes to get to the top, which would be at 500 feet. How long would it take to get halfway up the Ferris wheel? Well, that would be, that time is 7.5 minutes. And that height, halfway up the Ferris wheel, would be 250 feet. So as I move through, I'm going to go up 7.5 minutes would be 250. After 15, I'd be at the top at 500. Another 7.5 minutes, I'd be at 250. And then 0, and the pattern would continue on from there. Now, class, I gave you a little bit of time to think about this. Hopefully that's soaking in for you if you're at home. But it's going up by 250 every quarter turn around the circle. And the reason that it follows the pattern 3 times is because I choose to ride for 3 full turns. 3 times 30 is 90, so I ride the ride for 90 minutes. Okay, now let's graph that data. So if I make my y-axis my height, h of t, and if I make my x-axis my time, which is t in minutes, I could make, hopefully, some pretty even marks here all the way until I've got 90 minutes. So let's say I've got 7.5, 15, 22.5, 30, 37.5, 45, 52.5, 60, 67.5, 75, 82.5, and 90 minutes. So from there, I'm going to start at 0 and plot my points as evenly as I can. And accurately, of course. Okay, then question number 3 said, should the points on the graph be connected by straight lines? Describe the shape of the graph. Now let's think about that. If I go back and look at my Ferris wheel, notice that the Ferris wheel kicks out long before it begins to kick up. And then here at the midline, it's getting very steep here, and then shallow again, very steeply moving down, shallow again. So the answer is no. It should be a curve because the rate of change is not constant. Since the rate of change is not constant, we want a nice flowy curve to show that the graph is going to go out first and then up quickly and out first and up quickly. If we were talking about a linear function, we would be calling this slope. So if you want to think of it kind of like slope, that would be fairly accurate. Although when slope changes, we call it rate of change. So the slopes are different here, which is why this is not a linear function connected by a line. Okay, number 4 says a function f is periodic if its values repeat on regular intervals. So think about that. Think about tidal waves that come in and out. That's something you know about that has a period or is periodic. The tides come in the morning and go out, in the morning and go out, and that happens every day as the moon goes away and the sun comes out, and vice versa. That's a period. Graphically, that means that if the graph is shifted horizontally by c units, the new graph is identical to the original. As you can see, every 30 minutes of this graph, my graph is identical. Thus, for the smallest value of c this relationship holds is called the period. So what is the period of the Ferris wheel? How often does it take to complete a new cycle? That would be 30 minutes. You might want to write, in layman's terms, a period is the time to make one cycle. Okay, let's look on the flip side. On the back side of our notes, it says the midline of a trigonometric function is the horizontal line midway between the function's maximum and minimum values. So if I go back to the front, let's go ahead and make the midline with a dotted line. And continuing, the amplitude is the distance between the function's minimum or maximum value and the midline. So let's label our amplitude of this graph. Our amplitude is the same on top as it is on bottom because it's coming from the midline, and from 250 to 500 is 250 feet. So our amplitude of this graph is 250 feet. Okay, let's label just a few other things on here. Let's label the domain and range on our original graph, because in the first semester we talked a lot about domain and range. That's important to know. If I think about domain, I'm talking x values, or in this case t values. My domain would go from 0 to 90 minutes, and my range would go from 0 feet to 500 feet. Okay, in class, we talked about doing some problems on a separate sheet of paper, and you're going to do most of number 6 on your own, A, B, and C. I'm going to do D with you, and then you're going to do number 7 on your own as well. So let's look at D. A new wheel is designed, so let's just draw a little Ferris wheel here, that is 20 meters in diameter and must be boarded from a platform that is 4 meters tall. Assume the 6 o'clock position on the Ferris wheel is level with the loading platform, and the wheel turns in the clockwise direction, so the opposite way of before, completing one full revolution every 2 minutes. Suppose at time equals 0, you are in the 12 o'clock position. Maybe you're waving to mom or something. From time t equals 0, you'll make 2 complete revolutions, and then any additional part needed to return to the boarding platform. So, the things that were asked here are for the period, amplitude, domain, and range, and a quick little graph. Let's start with the graph. If I'm talking about something 4 meters up, that's going to be my lowest point, 4 meters. My highest point would be 20 meters later, so 4 plus 20 would be 24 meters. And then think about where your midline would be. The middle of 4 and 24 would be 14 meters. Now watch out, it's very easy to say, oh, 4 to 24, that's 12. No, that's not true. It's still just 10 meters is half of 20, but you've got to go up for the 4 meter platform. Okay, as far as time goes, we can start with 2 minutes. That's how long it takes to go all the way around. So then halfway would be 1 minute, and a quarter of the way would be half a second. So that would be a good interval in half seconds here, or half minutes, excuse me, so 30 seconds. And I went ahead and went to 4 since we were doing 2 complete revolutions. We're starting at the top, middle, bottom, middle, top, middle, bottom, middle, and back to the top. The problem is we cannot get off the Ferris wheel when we're on the top, so I'm going to go ahead and do another minute and finish out till I get to the bottom. I'm going to connect my line here with a nice smooth curve, or best curve I can do. My period, how long did it take to complete 1 revolution? To get back to the starting point, it took me 2 minutes. My amplitude, so that's the distance from the middle to the top or the middle to the bottom, that would be 10 meters. My domain is from 0 minutes to 5 minutes. And my range is from 4 meters to 24 meters. Okay, your homework is to finish the worksheet. Please do that and let me know if you have any questions.